All right, today I'm backing up a little bit in my notes. I believe I'm at the top of page 21. We'll talk a little bit about combined assignment operators. Combined assignment operators simplify certain commonly used equations. You do not have to use these at all. They're not required. They're supplements to the other operators that we've seen: plus, minus, multiplication, division. And by the way, this plus could also be for strings concatenation. And these work for that. And the one I didn't put on the list, though it works, is modulus. You can use modulus as a combined operator as well. But if you look at these, they look kind of funky. It's plus equals. Why would there be a plus sign on the left-hand side of an equal sign? Usually it's on the other side. Well, they're shortcut operators. A lot of people call them that, the shortcut operators. And here's what they look like when you use them in code. Okay. Count plus equals 1. Now, let me just do a little word magic here if I can, or LibreOffice. Let's see what I got available here. Come in. Remember that when I think about memory, I think of boxes. Right? So here's a box, and I can put stuff in that box. I can call this box count. I don't know why my cursor, oh, I know what. I can call this box count. I'd normally draw this up on the board, but I don't have a lot of, and you can't see it in the recording. So there's my variable called count. And inside there I can store stuff, and this one's probably an integer. So I might store 10 in there. So somewhere in my program, I might have a statement that says, well, let's first declare it, right? It's an integer called count. And Word's helping me out here, called count. And a little later I could do count equals 10. And what that means to me visually, when I'm visualizing memory, is I have this memory location, it's a box, and I just put 10 in there. What the combined operators allow you to do is change the contents of that memory. In order to use a combined operator, you must already have something in that memory location, a 0, a 10, something. What we often do in programming is this: count equals count plus 1. The reason I call it the variable count is because I'm counting things. Like what? I might count students. I might count the number of times the users made a login error, so when they hit the third one, I lock them out. I can count all kinds of stuff. What this says, if you look at it, it says take whatever's in the variable count, 10. Add 1 to it, 11. And put that where? In count. And so what happens when you do this, count equals count plus 1, is it takes whatever's in there, the 10, adds 1 to it, 11, and it replaces it with 11. A memory location can only store one value at a time. So when we say replace, when we put count on the left-hand side of the equal sign, whatever used to be in there is now replaced. This is so common. This kind of an equation is so common that there are shortcuts for it, like count plus equals 1. That means exactly the same as this. This says take whatever's in count and add 1 to it and put it right back into count again. Take whatever's in count, add 1 to it. So now if I had 2, that would bump it up to a 12. So this one changed it to 11. This one, same thing. This one seems to make more sense to Steve. He said, I understand that one. This one for some people is maybe a little confusing. Whichever one of those makes the most sense to you, you can use any of them. They're interchangeable. When I first saw these, it just kind of made my eyes roll back in my head, and I couldn't figure out what the heck are they saying there. And these aren't that new anymore. They've been around a while now. So feel free, and I'm getting used to them. Steve?
When you were telling us about variables, Volker, you always said only the variable goes on the left of the sign. Now you got this.
That's why this is so funky to me, because you're only one variable on the left-hand side of the equal sign. But that's what I have here, right? is still one variable on the left-hand side of the equal sign, but now I got the squirrely plus sign there too. I understand this is breaking my rules. So if you don't like that rule breaking, then stick with this one. Adding 1 to a variable location is so common that C# gives you this as well. Plus plus. Two pluses right next to each other. That does exactly the same thing, said add 1 to count. All three of those do exactly the same thing.
No, can you only use one?
No, good question. Thank you. Can you only use one? That's my next example. That's why I'm making room here. Okay. I can also do this. Count plus equals 10. Obviously, I can make this one a 10, right? You can put anything there. But yes, you can put 10s here, but plus plus always means 1. It's so common to add 1 to a memory location that there's actually a special operator just for that. Not all languages include these, but they're becoming very, very common. This one says take whatever's in count, add 10 to it, and put it right back into count, so now it becomes 23. As we go. And that's because I've got all these counts in a string. You don't normally do that. I'm doing it for examples. So this first one changed the count or set the count to 10. This one added 1 to that, made it 11. This one added 1 to that, made it 12, made it 13, made it 23. If you go online, you may see this. That also works. Put the plus plus in front instead of on the end. I don't particularly like that one, but the Swift book says that's the better way to do it. What's the difference? Because these are commands by themselves, like there's the beginning, there's the end, right? There's a semicolon. The difference between these two, there is no difference. But it is possible to embed this inside of another equation that does multiplication and division and modulus and more addition and more stuff. And then inside you find one of these. That's a bad idea. Not in my class, folks. Okay. The only time you embed one of these inside of another statement is when you're embedding them inside of a loop. That's Unit 6. We'll deal with it when we get there. In the meantime, if you choose to use this, it should be on a line all by itself. If you do it any other way, you're on your own. What this one does is does all the other math first, then it bumps it up. This one does all the other math, bumps this up, and then does all the other math. Don't even put those in the middle of an equation. I don't do it. It's a maintenance nightmare. Don't do it. You may put them on a line all by themselves. That you'll see a lot. And you'll see them inside of a for loop in Unit 6. So those are different ways to do those. So here's the same example. This is equivalent to count equals count plus 1. That's what I just typed up. Here's another one that says take whatever's in my variable called balance, subtract with it the recent withdrawal, and put it right into balance. So if I had a variable called, and now I'm just changing this, if I had a variable called balance, and let's say that's got $1,324.33. What type is balance? Decimal, right? Because it's money. Okay. And just for example purposes, I can assign a value to it right away. Right? And this is just for example purposes. Normally I don't do that. Now I can say that the balance, and let's create another variable that is also a decimal called withdrawal, and let's make that equal to, let's make it easy. Right? Now if I say the balance is equal to, this is the long way, and it's not real long, the balance minus the withdrawal, what happens? We take whatever's the balance, 1324.33, subtract from it 324.33, leaving us with 1,000. Where do we put it? Right back into balance, so this becomes 1,000. Where? That's my memory. That's just my way of visualizing the memory. So probably, do I have to? I'm just visualizing. Normally, I'd write this on the board, right?
No, but I mean, in the program though,
Where?
would it come up if would the decimal places still show?
Oh, that depends on how you display it.
Oh, okay.
All right. If I were to use the debugger and touch it, yeah, I'd get a bunch of zeros probably, or 1 0. But here, no, I don't put a 0.0 there. Here's the shortcut for this. So now I'm going to put this back. Okay, I'm going to comment this one out. It won't turn, well, let's make it green because I have a handy dandy key to do that. Nice try. Let's try again. There we go. Okay. And now here's the other way, the shortcut way of doing that. Balance minus equals the withdrawal. Does exactly the same thing. This says take the withdrawal, which is 324, subtract it from the balance, okay, and put it right back in the balance. Gives me the same answer. I still get 1,000. Some people like them, some people don't. As you gain more experience, maybe you'll like them a little better. But I was reading over one of Reen's most recent programs in the Swift class, and I almost missed that little minus sign in there. I'm looking at it going, balance equals withdrawal. Why is he, oh, no, wait, there's a minus sign there. Combined operator. They both work. We've seen plus plus. Okay, so this is going to make it 1,000, right? What do you think this does? That's a minus minus.
-1.
Subtracts 1. Okay, 1. Sometimes we're counting down. How many seconds do I have left? We count down from 100 by ones. Balance minus minus takes it down by $1. The other combined operators are a little less common. The multiplication equals, why am I multiplying something by something and then putting it right back in itself? That's kind of rare, but it can happen. Modulus, rare, though that's what Reen caught me on. And divide means exactly the same thing. All right, so if I said this, that the amount times equals, or let's do this, PCT percent times equals 100, I'm taking whatever's in the percent and multiplying it by 100. And leaving it in there, but multiplying it maybe in place if that helps you remember it. Times 100. Then I could reverse the process if I really wanted to. Divide it by 100 and put it in place in the same memory location box. Again, that's how I visualize memory locations as boxes. That's just in my head. It works well on the board. I can draw boxes. When you're doing those worksheets, maybe draw boxes for all the variables and put numbers in there, and as you change them, change them. Make sure you're working in the right direction, particularly when you're doing that playing computer stuff. Another example that we saw was with strings. So what does this say? In that box called full name, copy Voker into it. Now this is a copy, right? Take whatever's in here, Voker, copy it into there. Then I can say that the full name plus equals the last name. The plus in this case, because I'm working with strings, means concatenate, so it tacks the last name onto the voker that was in there in the first place, and we get a longer string. So maybe this would be a good one to draw a box on to visualize it. So here's my box, and let's say that's the full name box. It's a little hard in Word to get. I can probably put some text there. There we go. There's my full name box. And initially, what did it have in it? When I got here, what was in my full name?
Nothing.
Better answer? Better answer?
No.
Garbage. Garbage. If you think nothing, I'm perfectly good with that. Empty string is not true. This is not the empty string. If you want it to be the empty string, in my notes it says this is not a bad idea to immediately set it to the empty string when you create it. That way, poof, it's the empty string. That's not the same as nothing.
So that's why we're initializing or,
Well, sometimes I ask you to initialize in that worksheet, or sometimes I don't, right?
well, yeah. But the worksheet asks why. So
Why what?
garbage would be the answer.
Why what?
Why do you initialize or assign a value to a string variable when you create it?
Good. So your answer would be?
To prevent it from having garbage.
To prevent it from having garbage, to make sure you can immediately use it in equations, because if it's got garbage in it, C# will not let you use it in an equation.
Okay.
So yeah, those are both good answers. All right, so when I started here, now it has the empty string in it, which looks just like that. Okay. And then I said, whatever's in the first name, put that in here. Technically, it might have quotes around it, right? But that's obviously a string. Okay. And then concatenate to it, take whatever's in there, concatenate Gall to it. It's smushed, yes. But if you don't want it smushed, you could do this. There's a space in between there. Hard to see in Word because it keeps fancying my quotes up, and it's just too much of a pain to get rid of that. Okay. But that's really ugly. What does this say? Take whatever's in, it used to be voker, remember? Take whatever's in full name and concatenate to that a space and the last name, and put it back into the full name. This is not the way I would write this. That's very hard for me to understand. I'd have to look at that for a half a second, and that's too long. I got better things to do to figure out what it's doing. This is normally what I would do, and do it the long way. Take whatever's in the full name, add a space, add a last name, take that whole thing, put it into the full name. But if I undo, that does exactly the same thing. I think it's just a little more cryptic. My advice is when you're using these shortcut operators, if there's only one thing over here on the right, use a shortcut operator. It makes it shorter. But if this is complicated and big old formula thing, I wouldn't use the shortcut operators. I wouldn't. Doesn't mean you can't. Somebody asked me in the other class, can I use the shortcut operators in my design? They're becoming prevalent enough, I would say, okay. Yes. So these combined operators, these shortcut operators, just simplify some equations. Instead of this big old long huge thing, it's not so long. Here's a shortcut for it. And then don't forget about the plus pluses and the minus minuses for quickly adding 1 and subtracting 1, and we will use those a lot more when we get to Unit 6. Anything else here I want to talk about? Here's a zip code. Take whatever my zip code is. I'm guessing it's a 5-digit number. Text, but a 5-digit piece of text. And concatenate this to it to make it a zip plus 4. So when I'm done, I get this. This is the long version. The short version is up here, right there. Concatenate this to my zip code. Nice and short. Not too hard to understand once you understand combined operators. There are a couple of combined operators on your worksheets. That's why we need to talk about them, and you'll see them all over the web. Experienced programmers kind of like them. I think they abuse them sometimes, but you get the idea. There's the increment and decrement operators, plus, plus, minus, minus. You can put them in front, but I think this is a better way to do it. Take my variable, shrink it. Take my variable, bump it up by 1. Questions on those?
Are those calculations or equations only good for a method? Or like if you would use them in a, not a method, whatever. Like if you're doing code,
Yes.
would that change the value all the way through from one event to another?
Or if you had a field level variable, yes. If we had class level variables, remember the ones that everybody can share, then yeah. But normally, no, this just changes wherever. It doesn't matter where these variables are, whether they're local or class level, heaven forbid global, right? Doesn't matter. This changes that variable. At that, when we hit this command, it changes the balance. If another method later needs a balance, it's using the new updated version. There's only one copy of balance at any given time. Does that answer your question?
Yeah.
Okay. If others come up while you're doing the worksheet, got lots of help. Ask me, ask Green, go to the open labs. My commercials for those getting annoying, still better than political ads, so don't worry about it. We're just going to stay with it. Okay. If you got nothing else, we already talked about splitting lines. I did update my notes. I prefer you split before a dot. That's different in the printed notes. But it doesn't really matter to C sharp. If you split here, color dot and then blue on the next line, that works. But to me, this is a property of the color class. Keep the dot with the property. So I've changed that in my notes. But again, C sharp will yell at you if you split lines wrong. You can't log it. You don't have your laptop in there, do you? Okay.
I can log in.
Is that your machine?
No, but I can log in.
True. But not with Visual Studio version. Just leave it. Don't worry about it. I'm just curious if there's one of those lines, because I think there was one in Swift where you can say after 80 characters, give me a marker so I can see how far the indentation is. I don't think there's one in C sharp. The fact that you've never seen it just means we never looked for it, maybe. But would be nice to know. All right, back to our design. I don't think I need this. Close it. Don't save it. Here we are back to our design. We've coded up to here. All right, we've got all of our calculations done. And here's another piece of code, and I showed this to the other class. This was just for demonstration purposes. Okay, how can we split lines? And if I need to split a string literal, how do I do it? Split it into 2 and concatenate them. I don't really want to leave that in my program, but I want to leave it there so you can see it in case you need it as a reference in the future. This little button up here on my customized toolbar to the left of collapse allows you to comment out selected text. So I've highlighted that code. I click this, and it turns them into a comment. Comes in handy. The one next to it reverses the project process. And you can do that 6 months later if you wish. Highlight them first if they're commented out. This will put them back to live code. I used that a lot just this week. I was fixing a project that I write for Midstate, and there's big changes in it, but I was afraid to take code out because if I break it, I might want to put some of that back. So all I do is comment it out, and if it's still commented out the next time I go in there, I'll usually delete it. But it's good for testing, and it's good for me to leave some sample code in here. So we did the next bowling date, and in our design it says, all right, the next thing you're supposed to do is move the series that we've already calculated right there. Move that series into this label. Now I'm a little curious. Did I remember to name my labels? Label series, good. Label average, and label next bowling date. Your inputs, your outputs, your buttons will always have names. Because if you're not getting the information out of the inputs, why do you have them there? If you're not putting things into the labels, output labels, why do you have them there? So you're going to name them, and if you're never going to respond to a button click, why do you have them? They always have a purpose, so you always name them, and I did. Good. So my notes say, hang on a second, John. My notes say take label series and set it equal to the series. That's what what the design says. Go ahead, John.
Where is your program with the updated code?
Updated code should be in OneDrive, Programming Logic, Unit 4, in class, your Bowling 10. Download that.
I do. It doesn't have any of.
Doesn't have this stuff? I didn't update the most recent one on Friday.
Mm-mm.
Okay, hang on a second. All right, I tried this, and probably as expected, that didn't work. Why not? Series is an integer. What type is this? No. I heard text. No. What does it say? Look, I touched it. What does it say on the left-hand side? It's a label. Steve's going, no way, I can't read that. That's all right. That's why Miguel's up front. All right. Can read that. It's a label. You can't mix types. This is a label. I mean, look at it there. It's a label. When you say LBL series, it's a label. I've been harping. So how do I fix this before I finish harping? Bless you. You never mess with an object, right? Which component of that label do I want to change? Its font, its color, its size, its... Val?
Thing, I forgot the word. It's right there.
It's...
Property.
Which property? Look at these scores. It's text property. So I want to change the label's text property. In this class, you will never change the label itself. You will always change or do anything with the label itself. You will always do something with a property. And when it's text boxes and labels, it's most likely going to be the text property. It's still not happy because this is an integer and this is a string. Oh. So now what? We have to convert series to a string. The correct and best way to do that is use the built-in toString method. Every variable of any type, as long as you don't define it yourself, which is not this class, so of any type, has a toString method. So here for series, we're going to say toString. And you have to put the parentheses on there yourself. This says, hey you, integer, turn yourself into a string. Integers know how to do that. They'll take their best stab at it. When we turned the string into an integer, then we had to use parse, and that can fail. Because what if it's not really a number when we're done? Then it crashes. But the reverse, there's no way we can fail. We're taking a number and basically putting quotes around it. For the purposes of this equation, that is not changing series permanently to a string. What that really does is say, let's pretend the number is 420. It converts it to a string and say, here's your string. It doesn't take the original. It gives me a brand new string. Behind the scenes, this is all happening behind the scenes. Takes the number, turns it into a string. And then we store it in here, and now everybody's happy. Matt?
Can you use parse to turn it into a string?
No, parse says take a text. Whoa, careful, Volker. No, I wouldn't, because it's a lot harder.
Okay.
Parse says take a string, turn it into a number. That's what we use parse for.
Okay.
All right. This does the reverse. It's actually a little easier. Just say toString. And you have to do that for every variable that you want to spit out. So LBL average.text equals the average to string. And LBL next bowling date dot text. This is a label. That bowling date thing can get it confusing. It's not a date, it's a label. Dot text equals the next bowling date to string. Is it there? Yes. There. We translated our last 3 lines of our pseudocode, and we're not getting any red squiggles. So the translation, if we look at the design, says put this in the label. In the design, you don't put dot text. Any programmer worth their salt will figure that out. Okay. And we don't say convert it to a string because it's not necessary in all languages. So this is great for design. Okay. This is great for design, but when you translate that into C#, you have to know that I have to convert the series to a string because C# does not mix numbers and strings. So I have to convert the number, the series, to a string. I have to convert the date to a string. The only thing you can put into text without conversion is text. Another string. And we don't do that in output very often. No, we can't. Let's test it. Now notice my breakpoint's gone because now my program is finally spitting stuff out on the screen and I can use just my labels to test things. And here's another real quick test because I think I've verified this. What's my date picker set to? October 7th. That's today. That's weird. In the other classes, it changed them all. I know I didn't manually change them. And now it's stuck on the 7th. Why did it automatically update? We're going to fix it. So we're not going to leave it up to C#. We're going to fix it. I promise. But the date looks good, so I'm going to start. And I have some sample test scores in there already, so I don't have to type those in. I type those in for testing purposes. Click on calculate. Cool. Answers, okay, what's with that date format? Well, we didn't tell it how to display the date, did we? So it said, here, take this. And that's not bad. It's called a short date format. Not bad. And it is 14 days in the future, so that's good. Let's change this 100 to 102. Calculate. Ew. Now we got a problem. Got a couple problems. The integer looks pretty good, right? Integers, if you just two-string them, most of the time they look pretty good, unless you want commas, which we wouldn't here. But if the number ever got big enough that it was over 1,000, then we might want commas in there to make them look a little better. But if they're small integers, usually all you have to do is two-string them. Done. Doubles, on the other hand, and decimals, on the other hand, we can get carried away with decimal places. And if this were currency, how do I get a dollar sign in there? And what if I want a little more information on my date? What can I do? Of course, you check the notes. We two-string, but if you don't like the way the output appears, two-string allows you to provide formatting codes. You can tell two-string to format numbers in a certain way using codes, and these codes are strings, so you always surround them with quotes. N is a number format. Let's try that one just to see how it works on the average. In the parentheses, if you don't tell it how to format, it does it the best it can. In the parentheses, add a capital or a lowercase n. It doesn't matter. I kind of prefer upper, but I would say be consistent again. C# doesn't care. It'll use either one. The n says format this as a number. Well, what does that mean? Well, let's run it and find out. I'm going to put my test back to 102 so I get decimal places. Well, that's better. Not exactly what I want, but it's better. Now I get 2 decimal places. What n all by itself means is format this as a number. If you need commas, I'll put them in for you. And you get 2 decimal places. I don't want to. Okay. Then give it a number after the n for how many decimal places you want. Oops, now I'm running and it's not letting me change. So I gotta kill it. There we go. Put a number in after the n to designate how many decimal places you want. You can put a 0 there and it will show you none. By default, n gives you 2 decimal places. This is one of my favorite things to complain about. Why are you asking for 2? Would have given them to you anyways. Your answer, if I am ever one of those grumpy moods and I take points off because you did that, is because it's more obvious, it's easier to maintain, it's more clear how many decimal places I want. And I go, oh, okay, here's your half point back. Okay. So N2 is acceptable. I've kind of backed off of that a couple of years ago. I said, it's nice for you to know that N gives you 2 decimal places. I want 1. Let's test that. Cool. Notice it rounds. Oh, because this was 666666667, right? When you format, C# automatically rounds. Cool. That's what we want in most cases. So that's good. Watch what happens if I put this back again to my 101, which used to show up as just 101. Now I said, give me 1 decimal place, and I made it a 10. Right? Fine. Do it again. There we go. No matter what, even if it's a 0, you get 1 decimal place. What if you don't want to see the 0 if there's no, oh boy, now you're getting into it. I'm not going to ask you to do that. If you want it, then figure it out. It's programming. A very common question is going to start occurring here very soon. Can we do, the answer is yes, probably. Right. Figure it out. Look it up. Google it. Look in my notes. You can ask me. You can ask Reen, and if we're in a good mood, we'll tell you. But he might be in a good mood. You know how often that happens with me. I might point you to a page in the notes. Or I might tell you. Good question. Here's how. So, there's 1 formatting string. There are more. We can use a C for currency. So if you want to format a number, let's just practice that. Instead of an N, let's put a N1, take out the N1, put in a C. We're not going to leave that, obviously, because my series or my average is not going to be currency. I just want to show you what the end result looks like. You get a $sign. That's a floating $sign. It will stay attached to the number, and you automatically, just like N, get 2 decimal places. And most often when you want currency, that's exactly what you want. Yeah. So if you want currency, just say C, done. Uppercase, lowercase, doesn't matter. If you don't want decimal places, you can say 0. Here's an interesting fact. Watch this one. The average was 101.7, right, with 1 decimal place. Now there's no decimal places. It rounds up to 102, as it should, right? Because we had 101.6666, round that up, no decimal places, rounds up to 102. I said currency, so I got a $sign. If the number were big enough, I'd get commas. Always a simple mistake. It's always a simple mistake, right? It generally is. And Matt could have looked at that for 10 minutes.
I was trying super hard.
Yeah, he was. He was trying to solve it. He even had Alan looking at it, and the two of them going, I don't see it. And then I walk over, and 3 seconds later, well, I know what I'm supposed to see, number one. I've got 35 years experience. After 35 years, you'll look at programming logic beginning errors and go,
really?
Yeah. Probably after maybe 35 weeks. It might not take 35 years. Right? But that's what you're doing. You're learning. And I hope you don't get too frustrated by it, because it never stops. Right, Reen? We're still getting frustrated. In the third semester, they're getting frustrated. Reen's been programming a lot longer than that, and he's still getting frustrated. When does it stop? Never. There's always something. That's kind of what programming and networking is about. You've been learning the same thing in networking, right? Why won't this stupid computer boot? It's probably something simple. And you stare at it, and then you bring your networking instructor over, and they go, here, you got to plug this wire in, otherwise nothing's happening. Oh, geez, I knew that. It's the same. My car mechanic has the same problems, right? Why is this making that funny clacky noise? It's not supposed to. And it's funny how many people expect him to figure that out without looking around and spending hours troubleshooting it and not paying him, and then here's $10 for fixing it. Interesting. All right, currency format. Now let's get rid of that. Or, yeah, let's leave it for a second. Another format you can use is P for percent. Also gives you 2 decimal places, and it automatically multiplies your number by 100. So when you have 0.35, which is 35% stored as a decimal, this will automatically multiply it by 100, give you 35 without the decimal place, and 2 decimal places thereafter, 35.00, with a percent sign tacked on the end. So just for grins, let's change this to P. Our average is 101.666. It's going to multiply that by 100. We're going to get 10,001, 10,166, and so on, with a percent sign, just to show you how it works.
Now that's an average.
That's an average. All right. The good news is you don't have to worry about it. You do your calculations inside. And what score did I get on the test? I got 33 out of 50. What score did I get? You do the calculation, and then you format it for percent. 33 divided by 50 gives you a 66% or whatever. It's not even that. Whatever it is. But it's a decimal number. When you format it for percent, it automatically multiplies it by 100. Those of you doing quiz stats, don't multiply by 100. Well, I like to see my numbers at 76.7%. Good. You format them. You don't change them in your calculations. You never see those anyways. They're stored in RAM. So if you're doing the quiz stats program, when you do your math, just divide the kid's score by the total possible. Done. If you want to display it as a percent with 2 decimals, add that to your comments in your design. Then we'll do it when you write your program. So that's how we format numbers. 2 decimal places unless you designate otherwise. Upper or lowercase. Here's some more examples. Display the average with 2 decimals, with 1 decimal. No decimals, that'll get you commas with no decimals. That's how you get an integer. Quantity is probably an integer. If it's a large quantity, I want to see commas. And you have to format it. But I don't want decimal places. That's the 0. Currency, lowercase, percent with 1 decimal place. Multiplies by 100. All right, let's take 10 when we come back. I'm going to take a quick look at those checkpoints, see if there's anything important in there. Formatting, oh, I want to finish this. Hang on just a second. Formatting codes should only be used when you're transferring to your labels, when you're outputting. When you're outputting. Don't use N1s and N2s on your formulas. I want 2 decimal places in my answer. Let C# do its calculations with the full decimal places that it has available in its memory, and when you're done, format it. When you display it, not when you're calculating. You don't format calculations. I'm not going to say ever, but it's rare. Take this number, and if it's got 76 decimal places, I just want 2. Chop them off. For any further calculations, that's very rare. You only format output. You get a lot of students who want to format their calculations. No. Output. All right, now let's stop.